Hello everyone. Welcome to our lecture series on database management systems, paper code EC703C. Myself, Mr. Tridip Chakraborty, Assistant Professor from the Department of Information Technology, Guru Nanak Institute of Technology. So we have just started with a structured query language. We have done one lecture upon that. So we will continue with that, and we will see briefly about SQL data definition language and how to write single table queries using SQL. We will see some examples of that. Then how to establish referential integrity using SQL and different SQL standards. So let's begin today's lecture. So this is where we stopped in our last day's class. So I hope you remember these tables. We built 4 relational tables: customer, order, product, and order line. So in all these tables there were multiple attributes, and for all those attributes there were different data types specified by us, and also some constraint like primary keys also specified in those tables, right? So now we will see how to do some operations using data definition language and data manipulation language over these tables. Let's proceed. So here we can see how we need to define attributes and their data types. Like for the first table, that is the table named product. Here we can see we are having 3 product ID, product description, and product finish items. From these 3 items, product ID is number, product description is varchar2, that is variable character, right? For product finish, we are writing a constraint, that is check. That is product finish in cherry, natural ash, white ash, red oak, natural oak, and walnut. That is product finish. This should have any one of these items, either cherry, natural ash, white ash, or these 6 items, any one of these items. Anything else, like if you want to insert orange, then that won't be acceptable here, because we have written a constraint. Check is a keyword for putting a constraint in a table, right? So only these 6 values will be acceptable for this data type. Product standard price, how to write standard prices at a decimal is the data type, and 6(2) means after the decimal up to 2 points we will take for the standard price. And product line ID. Look, that product ID is specified as not null, right? And at the end we have defined that constraint product PK, that is the how we define primary key, constraint product PK primary key product ID. So product ID is a primary key of this relation, right? Okay, so this is how from our last example we put constraints, and we also define data types for relations. So product ID is not null here, and it is also the primary key. We have used another constraint for product finish, that is we need to check if product finish the value is in cherry, natural ash, white ash, red oak, natural oak, or walnut, right? So these are how we define the attributes and their data types. Now let's see the not nullable specifications. Because product ID is a primary key, that constant we have written at the end of the table. So product ID as a primary key can never have null values, because this primary key is used to define how all the entries are distinguishable from each other. So all the values which will belong under product ID are unique. So product ID is mentioned as not null. Okay. This is again for the table order line. We can see that both order ID and product ID, both are not null specified. So here we are seeing that some primary keys, both order ID and product ID, they're composite. That means they are formed using multiple attributes. In our case, order ID and product ID, both of them are being used to form the primary key for order line relation. Okay. And we can also see that the primary key order ID is being used as a foreign key for order relation. And product ID, this is being referenced by the relation named product underscore T. So the primary keys order ID and product ID for the table order line T are being used to set the foreign keys for order T and product T tables. And this is how we need to write these constants. This constant order line fk1. This is the name of the constant. So order line fk1. Order line fk1 is the name of the constant. When we are running the GGL statement, the statement must validate all the constants that we have specified beforehand. So order ID must be a foreign key for the order T table. And this we have confirmed by adding the constant order line fk1. So order line fk1 is the name of the constant which guarantees that order ID will be the constant. Now here is how we can control the values, that is the range of values or the data type of values in attributes. Suppose for the table order T, we are having order date as one attribute. Now the data type we are specifying as date. So date is one data type available in all RDBMS SQL packages. And we're writing the default is sysdate, that is referring to the system date. So whenever we are inserting data in the table, then if we don't specify any particular value for the order date, then by default, the system date will become the order date, right? So this is how we can control the values, because dates can have different formats like DTMM or MMDT or different formats. So which format the user is going to follow, we don't know. So by default, we are ensuring that the system date will be the order date, right? Now let's look at the next example, that is a domain constraint. Now, we just discussed that how we are using the check command. Okay, we're writing check product finish in cherry, natural ash, white ash, red oak, natural oak, and walnut. So we are putting some domain constraints. Okay, that is the product finish values should lie between these 6 items. Okay, now how to identify the foreign keys? Look at the customer table. The very first attribute, customer ID, which is the primary key. Now that primary key is being used as the foreign key for the order reference, right? See, after creating the table order, we're putting a constant order fk foreign key customer ID. So customer ID, the foreign key, references the customer table, so the dependent table. So order T is a dependent table upon a customer table. Look at both the tables. In both the places, customer ID is present, right? In both the cases, customer ID is present. But the customer ID will be a foreign key in case of order relation. It will be a primary key in case of customer relation. Right? Now we will see how we can control data dependencies. Okay, so we will start with data integrity controls, and we will see that referential integrity constant that ensures that foreign key values of a table must match primary key values of a related table in 1:m relationship. 1:m refers to the cardinality relationship, and this restricts the delete of primary records, updates of primary records, and insertions of dependent records. So referential integrity constraints ensures that foreign key values of a table must match primary key values of a related table into 1:m relationships. This restricts deletion, updation, and inserts of dependent records. So we will see now that how these constraints can be applied for updation relation performance for on a table. So here we are saying that the alter table statements allows us to change column specifications, like the definition is alter table, table name, the name of the relation, and alter table action, that is the action, So like if we want to add a new column with the default value, then we will write add column definition. If you want to change the name, then alter column name, and we will set the default value. Alter column name, drop the default, dropped column, that is totally dropping the column name, and add some table contents. For example, if we write alter table customer T, add column customer type, data type varchar2, default commercial. So here the alter table customer T adds the column named customer type, which is having varchar2 as data type, and the default value is commercial. So here the alter table statement allows us to change column specifications where adding a new column with a default value is given. Here with the table named customer, we have added a new column named customer type, which is of varchar2. The default value is commercial. This is how we can remove tables. We can drop table. This statement allows us to remove tables from our database schema. If we write drop table customer T, the table will be dropped from our previous customer relation. We can also add one or more rows to a table. Okay. Like the first example where we are inserting one or more rows. So we are writing insert into customer T values and a new values for that row 001 contemporary casuals, the item name, and all other details. So insert into command is used to add new rows in the table. Now if you want to insert a record that has some null attributes that requires identifying the fields that actually get data. Like if you want to insert into product T, then product ID, product description, product finish, product standard price. So that will insert 1 in table cherry 175.8. These values will be inserted into the table named product T. Now if you want to insert data into a relation from another relation, then we can write like here we are inserting data in the last example, inserting data from customer T table to CA customer T table. We can write insert into CA customer T, select star from customer T where customer state equal to CA. So that will insert data where the customer state is CA. First, it will fetch those data from customer T and it will insert those data in CA customer T. Okay. Now here is how we can create tables with identity columns. This is how we generated. We can use SQL 2008. Inserting into a table doesn't require explicit customer ID entry or field list. We can insert into customer T values like contemporary casuals. Here the table, customer T. Here the customer ID is integer and it's generated always as identity. So we have put some explicit instructions that while inserting values into the table, there is no need to enter customer ID by the user. This will start with 1, and we can increment these values by 1, minimum value 1 and maximum value 10,000, and no cycle. So the value will start with 1, and all the other values, they will be incremented. The customer ID will be incremented by 1, and maximum 10,000 is the upper limit for customer ID. These are the delete statements. Here is how we can remove rows from a table, delete certain rows, delete from customer T, where customer state equal to high. Right? So here is how we can remove rows, delete rows for a particular select operation. These are the all applications of delete statement. This is update statement, which is used to modify data already present in existing rows. So update is the command for doing that. So you can write update product T, set product standard price is 775, where product ID is 7. So that is updating the price of the product ID 7. Right? Now this is how schema definitions can be dealt with using SQL. We can do certain things like control processing, choice of indexes, file organization for base tables, for indexes, data clustering, statistics maintenance, index creation, of course, and speed up random or sequential access to base table data. For example, if we want to create one index named name IDX on customer T, then we can write create index name on customer T, where customer name field will make the index, will be used to make the index. Okay. Now select statement. Now this one is used for queries or single or multiple table. Now there are some clauses of the select statement. First select, then from, then where, group by, having, and order by. The select statement lists the columns to be returned from the query. The from statement indicates the tables or views from which data will be obtained. Where statement indicates the conditions under which a row will be included in the result. Group by indicates the categorization of results. Having indicates the conditions under which a category will be included. And order by sorts the results according to specified criteria. Right? So select statement lists the columns which are to be returned from the query. From indicates the tables or views from which data will be obtained. Where indicates the conditions under which a row will be included in the result. Group by indicates categorization of results. Having indicates the conditions under which a category will be included, and order by this sorts the result according to specified criteria. But this is the SQL statement processing order. This one is very important for our study. The from clause identifies the involved tables. That is the first clause, the from clause. Then the where clause finds all rows meeting the stated conditions. Group by clause organizes rows according to values in stated columns. Having clause finds all groups meeting stated conditions. And select, this identifies the columns. And finally order by, which sorts the rows. And finally we will get the result. So this is the flow chart. So some points we need to observe, like starts from identifies involved tables, right? So from there we can directly jump to group by, from where we are finding all rows meeting stated conditions. We can jump to select, identifying columns. After doing group by, the result, we can again select, identifying columns, and order by and select, identifying columns. They both can give us results. So that depends upon the particular query we are dealing with. Now this is the select example. So we can find products with standard price less than $2.75. That is our query. What will be the query for that? Then this is in the table. There are some comparison operators that are frequently used in SQL. That is equal to, greater than equal to, less than, less equals to, not equal to. And there are two kinds of not equal to. Both are used for the almost same purposes. We will use some different purposes too. So these are the operators available for comparison. The select product description, product standard price from product T, where product standard price is less than $2.75. This is an example of comparison operator. So here we are comparing the value of product standard price and all those products whose value are price are less than $2.75, their description and standard price will be listed. Another example of using select or upon the alias. Alias means just putting a duplicate value. This is an alternative column or table name. Select cast.customer name as name, cast.customer address from owner id.customer T as cast, but name is home furnishing. Here cast is a table alias and name is a column alias. So alias is a way to put alternative column or table name, and we are seeing one example where cast.customer name we are using as name. Name is a new alias. And owner id.customer T, we are naming, putting a new name as cast. So cast is here a table alias and name is a column alias. Okay. Now we will see some select example using a function. We can use the count aggregation function to find totals. So here we are using select count star from order line T, where order ID is 1004. Okay. Here with aggregate functions, you can't have single valued columns included in the select clause unless they're included in the group by clause. So using the count aggregate function, select count star from order line T, where order ID is 1004. Here the aggregate functions, we cannot have single valued columns included in the select clause unless they are included in the group by clause. So count is one aggregate function. So for order ID 1004, we can have the total number of counts. Now we can't have single valued columns included in the single select clause unless we are using group by clause. Here we will see some Boolean operators like and, or, and not to be used in one SQL statement. Select product description, product finish, product standard price from product T, where product description like percentage desk or product description like percentage table and product standard price is greater than 300. So the like operator allows you to compare strings using wildcards. For example, the percentage operator can be used as wildcard. So the percentage operator in percentage desk indicates that all strings that have any number of characters preceding the word desk, those will be allowed. Right? So percentage is one wildcard and percentage desk indicates that all strings that have any number of characters preceding the word desk, so all of them will be allowed. So and, or, and not operators are used for customizing conditions in where clause. These are all Boolean operations. Here we can see the or and operator to how they are being used. And we are also getting the result. Okay. Now this is a Venn diagram to see how and, or, and not is being used upon the SQL query and how finally the result will be printed. So this we will see in detail in our continuing lecture. We will start from Boolean operators and what are the effects of putting parentheses in different places. That is by default, what is the processing order of them, and if we want to override the precedence rule, how we can use the brackets over them. Right? So in our continuing lecture, next lecture, we will see how to use operator precedence and how we can override that. So till then, thank you for joining today's lecture.